Hello everyone, and welcome to this lecture series on climatology. In this first module, we are going to lay the foundation for understanding climate and weather by diving deep into the principles, aims, scope, and essential elements of the subject. We'll explore the dynamics of Earth's atmosphere, the processes of radiation and heating, the role of atmospheric moisture, and the mechanisms that drive pressure and wind systems. By the end of this module, you should have a strong grasp of the physical and dynamic processes that make our atmosphere work the way it does. 1. Principles, aims, and scope of climatology. Climatology is the scientific study of climate, which is essentially the average pattern of weather over a period of time, often measured over decades or centuries. It's not just about recording temperatures or rainfall, it's about understanding the interactions between the atmosphere, oceans, land surfaces, and living organisms. The principles of climatology are rooted in atmospheric physics, thermodynamics, and environmental science. They help us explain why climates differ across the globe and how human activity may be influencing climate patterns. The aims of climatology are to understand the causes and effects of climate variations, predict future climate trends for agriculture, industry, and policy planning, support sustainable development through climate-informed decision-making. The scope is broad. Climatology examines everything from the microclimate of a small farm to the global patterns that drive El Niño events. It connects closely with meteorology, geography, oceanography, and environmental science. 2. Elements of climate and weather. The basic elements of climate and weather are the measurable variables that describe the state of the atmosphere at a given time and place. These include temperature. This is a measure of the heat energy in the atmosphere. It varies with altitude, latitude, time of year, and proximity to oceans. Precipitation, the release of water from the atmosphere in the form of rain, snow, sleet, or hail. Humidity, the amount of water vapor in the air, which affects comfort levels, precipitation, and cloud formation. Wind, the movement of air from high pressure to low pressure areas. Atmospheric pressure, the weight of the air above a given point, which influences wind and weather systems. These are the building blocks of climate description, and understanding them individually helps us make sense of larger climate systems. 3. Elements of climate and weather. In addition to the primary elements, there are other important atmospheric parameters. Cloud cover, the amount and type of clouds present can greatly influence temperature and precipitation. Sunshine duration, the number of hours of sunlight impacts temperature and plant growth. Evaporation and evapotranspiration, processes by which water returns to the atmosphere, influencing humidity and precipitation cycles. Visibility and atmospheric transparency, often affected by fog, pollution, and particulates in the air. Together, these elements form the climate profile of any location. 4. Dynamics of Earth's atmosphere. The atmosphere is a complex system of gases held to the Earth by gravity. It is made up of layers, each with distinct characteristics. Troposphere, the layer where weather happens and where most of the atmosphere's mass is located. Stratosphere, contains the ozone layer, which protects life by filtering harmful ultraviolet radiation. Mesosphere, the layer where meteors burn up. Thermosphere, high-energy solar radiation is absorbed here, creating the auroras. The dynamics refer to the movement of air masses, the circulation of winds, and the interactions between atmospheric layers, which are driven largely by uneven heating from the sun. 5. Radiation and heating of the atmospheric system. Solar radiation is the primary energy source for our climate system. This energy arrives in the form of shortwave radiation, some of which is absorbed by the Earth's surface, warming it. The surface then emits long-wave radiation back toward the atmosphere. Key processes here include reflection. Some solar radiation is reflected by clouds, atmospheric particles, or the surface, especially ice and snow. Absorption. Energy is absorbed by the land, water, and atmosphere. Re-radiation and the greenhouse effect. Certain gases, such as carbon dioxide and water vapor, trap some of this outgoing energy, keeping the planet warmer than it otherwise would be. 6. Atmospheric moisture. Water vapor is a small but crucial component of the atmosphere. It plays a key role in cloud formation, through condensation of water vapor into droplets. Precipitation, when these droplets combine and fall to the ground. Energy transfer. The latent heat released during condensation fuels weather systems like thunderstorms and hurricanes. The capacity of the atmosphere to hold water vapor is dependent on temperature. Warm air can hold more moisture, which is why tropical climates are humid. 7. The dynamics of pressure and wind systems. Atmospheric pressure differences drive wind. These differences arise from unequal heating of the Earth's surface. Warm air rises, creating areas of low pressure, while cooler air sinks, creating high-pressure zones. The main types of wind systems are trade winds, steady winds found in the tropics. Westerlies, winds in the mid-latitudes that move from west to east. Polar easterlies, cold winds near the poles. Wind direction is affected by the Coriolis effect, which causes winds to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. 8. Condensation and the precipitation process. Condensation happens when water vapor cools to its dew point and changes into liquid droplets. This process requires condensation nuclei, tiny particles such as dust or salt in the atmosphere. The types of precipitation include rain, liquid droplets falling when temperatures are above freezing. Snow, ice crystals that fall when temperatures are below freezing. Sleet and freezing rain occur when raindrops freeze before or after reaching the surface. Hail, formed in strong thunderstorms when updrafts repeatedly lift droplets into freezing layers. 9. Seasonal variations in temperature and daylight. The tilt of Earth's axis and its orbit around the Sun cause the seasons. In summer, a hemisphere is tilted toward the Sun, resulting in longer days and more direct sunlight. In winter, it is tilted away, leading to shorter days and less intense sunlight. These variations influence agriculture, energy use, and human behavior, and they are a key driver of climate diversity around the world. That completes Module 1, where we have established the basic physical principles and processes that underpin climatology.